AQA A-level chemistry inorganic topic 3 patterned. Calm. Reactivity, yeah? So group 7 elements, yeah, they're called halogens, yeah? And these need to gain an electron, obviously, because they're non-metals, innit? So basically, yeah, they need to gain one electron to have a full outer shell, yeah? Because obviously these men have 7 electrons on the outside, yeah? As the atomic radius increases down the group, yeah, we've established that, yeah, as you go down the group, yeah, you get like more shells, yeah, so the atomic radius increases, yeah. It becomes harder to attract an electron naturally, yeah, because the atomic radius increases, yeah, therefore the distance, yeah, from the nucleus here and the outer shell becomes like very long in it, yeah, long distance, fam, yeah. So that's why it does that, yeah. And then this is because the nuclear attraction is weakened by the shielding of each shell as well, yeah. And then hence reactivity decreases, yeah. Since it's harder to accept an electron down the group, yeah, therefore it's going to be harder for like halogens to react, isn't it, yeah? Alright, calm. Boiling point, yeah? Halogens are simple covalent molecules held together by van der Waals forces, yeah? The strength of each van der Waals force increases as the AR of the molecule increases, yeah? So as the AR increases, yeah, naturally, obviously, like van der Waals also increases in it. So therefore, same thing with halogens, yeah? As you go down and you have more protons, yeah, you have more electrons, yeah? There's more van der Waals forces, yeah? Hence the boiling point increases down the group, yeah? Fluorine is gas at room temperature, whereas like iodine is a solid, in it. You might see iodine as like water, yeah, like liquid, yeah, but that's because iodine solution, yeah, it's not just iodine, yeah. Calm. Oxidizing power, yeah. So to oxidize something, you need to be reduced yourself, yeah, because in order to make something else lose an electron, you need to gain an electron, yeah. So oxidizing power decreases down the group again because it's going to be harder, yeah, down the group, yeah, to accept an electron, yeah. So therefore, oxidizing power decreases down the group. It's harder to get reduced itself, yeah. When a halogen reacts with a solution containing less reactive halide ion, it can displace a less reactive ion from its compound, yeah. This displacement reaction occurs because the halogen atom has a higher affinity for electrons compared to the halide ion. The greater the reducing power, the longer this reaction is, yeah. So basically, yeah, with the halogens, yeah, they can basically displace, yeah, like the less reactive halogen, yeah, from the compound, like halogen below it, yeah. So what do I mean by this, yeah? Is I mean that certain halogens, yeah, that are more reactive than other halogens, yeah, they'll displace in the reaction, fam, because they'll be easier to accept an electron compared to other halogens, yeah, especially if that halogen already has an electron accepted, yeah. So like for example, Cl2, yeah, will displace Br minus and I minus ions, yeah. So remember this, yeah. A halogen atom, yeah, will displace, yeah, a halide ion beneath it. So if you look at the periodic table, yeah, Cl then Br, wherever, yeah. Cl is above them, so it displaces the Br and I ions, yeah. Br will displace I ions, yeah. I2 won't displace any ions, yeah. The reason being is because deep it. Cl needs to attract one electron, yeah. Br2 already has an electron added to it, fam. And at the same time, it's further down the group, yeah, so it's harder to even attract an electron. So how is that gonna accept another electron? It can't. It's already bare hard for it to accept an electron, yeah, because Br is hard for it to accept an electron compared to Cl, yeah, because it's further down the group, yeah, so more shielding and whatnot, yeah. And now it already has another electron as well, so it becomes even harder, fam. So do you see why Cl2 will displace Br minus and I minus ions, yeah? So for example, if like a compound had Br something, let's say HBr, yeah, Cl2 would displace the Br in that sense, yeah. And yeah, you understand? And obviously Cl will become ionized, yeah? It'll be HCl or whatever, yeah? Also, yeah, the greater the reducing power, so if the halide ion has a higher reducing power, yeah? The longer the reaction as the halide is powerful enough to reduce more species. So if it has a high reducing power, it can keep reducing, yeah? So like, the reaction will keep going on, yeah? Alright, halide ions, yeah? The negative ions of halogens are known as halide ions. They are good reducing agents as they donate electrons to the species being reduced, yeah? Again, reducing power increases down the group, yeah? So reducing power means you reduce something else, which means you yourself oxidize, yeah? So you need to lose an electron. Again, deeper, yeah? Down the group, yeah? It gets harder to accept an electron. So if down the group there's more shielding, yeah? There's more atomic radius, yeah? That means that the electron's going to be further away from the nucleus. It's going to feel less attraction. So therefore, yeah? It's going to be easier to lose that electron. And on top of that, yeah? Halide ions are also very good at this, yeah, because they already have a max outer shell now. They're ions, yeah, so they already have that negative electron. They gained an electron, so they can easily just give that electron back. Do you see what I'm saying? And that reducing power increases down the group because the group, like, more shells and whatnot, yeah? Alright, calm. Calm. So in chemistry, yeah, you got these, like, little bare equations, yeah? You need to know about these, yeah? You need to know about them, yeah? So make sure you memorize it. Trust me, just take the time. It's worth it, bruv, yeah? Because trust me, this will gain you like 10 marks or something, fam, yeah? Just sit down and just write this bare times on a sheet of paper and just memorize it. It's worth it, man. Do it whilst you're young. Do it while like you still got time. You get me? Yeah, you don't want to be doing this like the second before the test, bro. Yeah. NaF, yeah, plus H2SO4 gives you NaHSO4 plus HF, yeah. Calm. NaCl plus H2SO4 gives you NaHSO4 plus HCl, yeah. There's not much going on here, fam. You literally just need to memorize this. That's all that's going on here. You understand? You just need to memorize this, bro. As you see, one H became with the Na here. One H became with the Na. Same shit going on. Next one here is for bromine ions, yeah. So you can write these in like a list, yeah. So call this fluorine or whatever, and chlorine, yeah. And then this one you can call it bromine, yeah. So bromine, NaBr plus H2SO4 does the same shit as the other two. So you can memorize those three are pretty easy, yeah. Then 2HBr plus H2SO4 becomes Br2, SO2, and 2H2O, yeah. NaI plus H2SO4, like exactly like the other three before. This one's like the bromine one. And then this one you got 6HI plus SO2 makes H2SO, H2S, 3I2, and 2H2O, yeah? So just make sure you memorize all these equations, yeah? Alright, test for halide ions here. So you can add acidified sodium nitrate, yeah, to halide ions here, and that will create something. So you can put it on chlorine first here, and chlorine will make a white precipitate, fam. Yeah? Also, if you then add dilute ammonia, yeah, the precipitate dissolves. And if you add concentrate, it also dissolves, yeah? Then, if you add sodium nitrate, silver nitrate, yeah, to Br minus, it makes cream precipitate, AgBr, yeah? Bromine's always cream, by the way. Chlorine's always makes white, yeah? You can think of chlorine like bleaching something, yeah? Bromine's always like cream, yeah? And then I minus here is always like yellow, bruv, yeah? That's the situation, yeah? Iodine always makes something yellow. So you got dilute NH3, yeah? You add that to Br minus, you add that to AgBr, it makes no change. Add that to this, it makes no change. But when you add concentrated NH3, yeah, the silver bromide, yeah, it dissolves in it. Whereas like silver iodide, yeah, it doesn't do anything. It's still no change, yeah. So just memorize this, yeah. This is the test for halide ions. I can ask you, they can say, how can you test for Cl minus ions, yeah? And you can say, add this, it will give white precipitate. That indicates that's AgCl. You want to test it further, add dilute NH3, and it will dissolve. Or you can add the concentrated NH3 and it can dissolve, yeah. Chlorine reacts with cold water, yeah. And this is a disproportionation reaction, yeah. If you watch the redox video, yeah, you should know about this. I'm pretty sure I put this example there as well, yeah. But disproportionation reaction, yeah, is when like one item, yeah, one species, yeah, is oxidized and reduced at the same time, yeah. So as you see here, again, you need to memorize this equation, yeah, because we'll ask you, it'll be like, what's a reaction with chlorine with cold water, yeah. In inorganic, there's bare questions like equations you need to memorize, yeah. So here, yeah, chlorine goes from 0 because you know atoms have 0, yeah. Oxidation number, yeah, and then here you got O minus, right? And that's going to be 2 minus, yeah, but it needs to add up to -1, so Cl has to be +1 here, yeah. So you see how it went from 0 to +1, and then Cl minus here has to be -1, obviously, yeah, because it's Cl minus, yeah. So do you see what I'm saying? It went from +1 and to -1, so it got oxidized to +1 and got reduced to -1, yeah. In UV light, chlorine decomposes water, yeah, to produce oxygen and hydrochloric acid, yeah. Chlorine is also used in small quantities to kill bacteria in water treatment processes, yeah. Chlorine is toxic, however, the benefits outweigh the cons, yeah. Calm, so again, you need to memorize this equation, yeah. 2Cl2 plus water, yeah, breaks down UV light, it decomposes the water into 4HCl plus O2, yeah. Bleach production, yeah, again, another equation you need to memorize will be like, what's the state the equation for bleach production, fam, yeah. You can't let them catch you off guard like that, you know what I'm saying, yeah. Chlorine can be mixed with cold aqueous sodium hydroxide to produce sodium hydrochloride, yeah. This is a very important ingredient in bleach production, yeah. So again, memorize this equation. NaOH, 2NaOH, yeah, plus Cl2 gives you NaClO plus NaCl plus H2O, yeah. Test for sulfate ion, yeah. Again, this was in a previous video, yeah. I'm pretty sure in part 2, yeah, of inorganic, yeah. But, you know, I'm not a dickhead, so I'll write it for you again, yeah. Barium chloride is used in the test for this, yeah, and it produces a white product, yeah, and I'll give you the equation again, yeah, it's Ba2 plus SO4 2 minus gives you BaSO4, yeah. Pattern. Hydroxide ion testing, yeah. This can show if a substance is alkali, yeah, because the deeper it sounds alkali, yeah, then normally has that OH. That's one way to indicate that's alkali, yeah. And hence the red litmus paper will turn blue, yeah. Or you can use universal indicator, which will turn blue-purple, which indicates that's an alkaline substance, yeah. Litmus paper, red will turn blue, that indicates that's alkali, yeah. carbon ion test, yeah, so memorize this as well. When an acid like HCl is added to the whatever has a carbon ion, yeah, the substance that contains the carbon ions will cause effervescence. And CO2 gas is given off, yeah. So effervescence is like fizziness, yeah, like it creates carbon dioxide gas, yeah. And this gas can then be collected, yeah, like this. You see this diagram here, it gets collected, this gas, and it gets bubbled into lime water, yeah. And lime water turns cloudy when there's carbon dioxide, yeah. So that's how you can show that it's has carbon ions, yeah. Because then you put down there and it becomes like milky, yeah. I can't flame test. These are basic, man. Just calcium brick red, strontium red, and then barium pale green, yeah. Ammonium ion test, yeah. If ammonium ions are present, the ammonia gas is given off, which is a base, yeah, obviously, yeah. Uh, Therefore, the presence of ammonia ions can be tested by holding red litmus paper over a petri dish of a substance being tested. It will turn blue if ammoniums are present, yeah. Because again, this is alkali, yeah, basic, yeah. Calm. They can be tested in the same way, but by adding NaOH if you want, which produces ammonium gas even faster, yeah. That's it, man. Easy, easy.